Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading and sometimes singing. Continue with The Cat in the Box, câu chuyện số 19, về một trong những gọi là famous and my favorite scientist, or you can say that nhà khoa học, Antoine Lavoisier. Animal heat, but no animal magic. Although earlier experiments, such as those of Priestley and Ingersoll, had shown the importance of some components of air in maintaining life at the beginning of 1780s. The details of the process were still far from clear. Like many of his colleagues, the French chemist Antoine Lavoisier, a member of the French Academy of Sciences, speculated that the process resembled a slow form of combustion, with the life-giving component of air being converted into fixed air, carbon dioxide, by in effect being burned in the body. But unlike those colleagues, Lavoisier, together with his fellow academician Pierre Laplace, carried out a proper scientific experiment based on quantitative principles to test the hypothesis. Their experiment involved a guinea pig, which was placed in a container within another container, itself insulated from the outside world, with a gap between the two containers filled with snow at 0 degrees Celsius. Under these conditions, the animal was quiet and did not move about much. They waited for 10 hours and collected measured the water that had melted from the snow as a result of the warmth of the guinea pig's body. It came to 13 ounces, or 369 grams. Then, in a separate series of experiments, Lavoisier and Laplace measured how much fixed air in the animal breathed out in 10 hours while it was resting. Finally, they compared the guinea pig measurement with the amount of snow that could be melted by burning enough charcoal to make the same amount of fixed air. This was slightly less than 13 ounces, but the agreement was close enough to convince Lavoisier and a wider circle of scientists that animals keep warm by combining the substance now we call carbon, obtained from their food, with something from the air, oxygen, to make fixed air, carbon dioxide. This was a key step in seeing animals, including human beings, as systems obeying the same laws as burning candles or falling stones. It was Lavoisier who gave oxygen its name, and who established that burning does indeed involve oxygen from the air combining with the burning substance. This replaced the old idea, still adhered to even by people such as Priestley, that a substance called phlogiston is escaping from the substance as it burns. Lavoisier published his definitive demolition of the phlogiston model in the Memoir of the French Academy in 1786, using the term air where we would say gas. 1. There is true combustion, evolution of flame and light. only insofar as the combustible body is surrounded by and in contact with oxygen. Combustion cannot take place in any other kind of air or in a vacuum, and burning bodies plunged into either of these are extinguished as if they had been plunged into water. 2. In every combustion, there is an absorption of the air in which the combustion takes place. If this air is pure oxygen, it can be completely absorbed if proper precautions are taken. 3. In every combustion, there is an increase in weight in the body that is being burned, and this increase is exactly equal to the weight of the air that had been absorbed. 4. In every combustion, there is an evolution of heat and light. Lavoisier also gave them modern names to many other substances and produced the first list of 33 chemical elements, as well as introducing a system of symbols to represent the elements, although not all of them turned out to be elements as we know them today. The key point, though, is that he discarded the old idea of 4 mystical elements, earth, air, fire, and water, and replaced it with the idea of an element as a substance that could not be broken down into any simpler substances using chemical processes, while more complex substances were made by combining elements. Indeed, Lavoisier's definition still stands. We must admit as elements all the substances into which we are capable by any chemical means to reduce bodies by decomposition. His naming system used logical rules based on this idea, so that, for example, vitriol of Venus became copper sulfate. His book, Traité élémentaire de chimie, Elementary Treatise on Chemistry, was published in 1789. Note the year of the French Revolution, and laid the foundations of chemistry as a proper scientific subject. It is seen by chemists as their equivalent to Isaac Newton's Principia. Lavoisier also spelled out clearly what we now call the law of conservation of mass, which states that matter is neither created nor destroyed in chemical reactions, but only converted from one form into another. In the same year, he also founded a journal, Annales de Chimie, which carried research reports about the new science. As far as such things can be pinned down to a specific year or a specific event, the publications of Lavoisier's book marks the moment when chemistry shed the last traces of alchemy and magic and became the proper scientific discipline. Alright, for vocabulary, let's practice a few terms. Colleagues, resemble, resembling, combustion, combustible, combust, combustion, yeah. Guinea pig, adhere, adhere to, adherence. Phlogiston. This word, I don't think you have to remember. Phlogiston. Demolition, demolish, demolition, demolish. Discard, discarding, discarding, discarded. Interesting, huh? Alchemy and magic. Alchemy. Hồi xưa người ta thích, người ta muốn làm vàng, làm ra vàng thau từ các kim loại khác, thì cái đó gọi là alchemy. Anyway, I hope you like this story. I love reading about Antoine Lavoisier. He actually died a few years later, maybe 4 years later, 4 or 5 years later, after the French Revolution started, in the wave of terror. So sad, because had he lived, we would have been benefited from his life a lot more, I think. In any case, he's a man of history, my hero. Okay, so see you in the next story. Thank you for your time, and bye for now.